the epidermis of thick, the epidermis of thin, hairy skin has just 4 layers, from superficial to deep: corneum, granulosum, spinosum, and basale. So that's corneum. That's granulosum. And all this purple running along there is stratum spinosum. What they failed to show you is one innermost layer running along the curves here. Should be one layer of cells called the stratum basale. So it should be 1, 2, 3, and the 4th bottom layer running along the curves, the stratum basale. For whatever reason, they failed to paint in the stratum basale. Shame on them. All right. Let's see. So the dermis is all the pink, and all of these projections here are dermal papillae. The papilla is Latin for nipples, all these little dermal nipples sticking up. Dermal papillae projecting here. And you can see capillaries going into those dermal papillae. That's as close to the surface as capillaries get. So the epidermis is keratinized, stratified squamous epithelium. And being epithelium, it is, by definition, avascular. So that's as close to the surface as any blood vessels are going to get, the dermal papillae. Okay? So I mentioned that if you scratch your skin and you bleed, you've gone all the way through the epidermis and into these dermal papillae. Okay, so the dermal papillae are found in the portion of the dermis known as its papillary layer. Now they split the papillary layer this far down. They went a little overboard. Papillary layer is actually quite narrow. It just goes a little bit below the papillae, along across here. The papillary layer does indeed include the dermal papillae, but not much deeper to that. So what's deeper to that is the remainder of the dermis, which is called the reticular layer. So this is definitely reticular layer here. This is definitely papillary layer up here. The question is, what do we do with this stuff here? I would argue that's also reticular. They cut it too deep here. So how do you really tell the difference between, say, with real tissue? You stain the dermis from superficial to deep. Stain it all the way through. And the papillary layer is paler, noticeably more pale than the reticular layer, because the reticular layer, which is the broader portion of the dermis, has a lot of reticular fibers that are very stain absorbent. So very few reticular fibers in the papillary layer, so not as much stain absorbed, so it looks lighter in color. You can actually see a pale strip, and then the rest of the dermis is obviously darker when you stain the dermis, which they have not done here. Hypodermis, where the adipose tissue is, hair follicle, base, top, right there, there's one complete hair follicle, there to there. This is the hair bulb, the rounded bottom of the follicle. Your handout says the hair bulb is the rounded bottom of the hair root. That's not true. The hair bulb is the rounded bottom of the entire follicle, okay? Not just the bottom of the hair root, the bottom of the entire hair follicle. Okay, so hair bulb. The dermal root sheath is what we see as the surface layer. We see the dermal root sheath here. We see the rector pili muscle attached to the dermal root sheath. We see a sebaceous gland wrapped around the follicle here as well. The oil secreting gland right there. And longitudinal section of this follicle reveals the hair root. All the brown is the hair root. That is the hair inside the follicle. Root. The hair outside the follicle is the hair shaft. So there's the end of the follicle right there. So this is all hair shaft leaving the follicle. Now, Pacinian corpuscle, a deep sensory receptor all the way down here in hypodermis, as you see. It will require heavier touch to get this to respond. There's a Meissner's corpuscle in this dermal papilla of thin, hairy skin. That's wrong. You don't find Meissner's corpuscles in thin, hairy skin. You find them in thick, hairless skin. So, yes, you do have sensory receptors, shallow, superficial sensory receptors, but they're not Meissner's corpuscles. They're American discs instead. So that's wrong on here. two layers. We've got the outer layer of the dermal root sheath, and then the pink inner layer. It's strictly speaking called the epidermal root sheath. That's what gives rise to the hair itself. Hair derives from epidermis. One last model. This one shows both thin, hairy skin, from here down to here, and thick, hairless skin, from here over, down to there. Strictly speaking, skin would be epidermis and dermis. So all the pink again is dermis on here. And then the yellow adipose tissue is in hypodermis, or subcutaneous layer. So the epidermal layers of thick, hairless skin, 5 of them, from superficial to deep: corneum, lucidum, granulosum, spinosum, basale. Labeled here is A, B, C, D, E. How convenient. So A, stratum granulosum; B, stratum lucidum; C, stratum granulosum; D, stratum spinosum; and E, this orange curving layer, is the stratum basale. Okay? Move over to thin, hairy epidermis. You notice that lucidum, layer B, is not there. It has the other 4, but it doesn't have the stratum lucidum layer. And again, notice that the stratum corneum here is far more stratified, many more layers of dead cells than the stratum corneum there. So the reason why it's so much thicker has less to do with the presence of the lucidum than it has to do with the extra stratification of the corneum layer here. The palms, soles, and lips then have super stratified stratum corneum. Any questions so far? Anything coming to mind that you want to ask? All right. So here we see a Meister's corpuscle and a dermal papilla. Meister's corpuscle and a dermal papilla right there. We do not see it, so this is thick, hairless skin. When we come over to thin, hairy skin, we don't see any more Meister's corpuscles because they're located in the dermal papillae of thick, hairless skin. Actinian corpuscles, on the other hand, are found deep within both types of skin, usually right around where the hypodermis and adipose tissue can be located. Let's see, hair follicle, longitudinal section. Here's a surface of the hair follicle. The rounded bottom is the hair bulb. The indentation into the hair bulb, excuse me, the indentation into the hair bulb is called the hair papilla, and we see it receiving capillaries. So this provides the oxygen to, removes the CO2 from, metabolizing hair follicle tissue cells. Let's see, erector pili muscle attached to the follicle, sebaceous gland around the follicle. There's a little piece of sebaceous gland here. This one does a really nice job of showing the sebaceous gland wrapping around the follicle. Now we're seeing erector pili muscle join that follicle. So in thick, hairless skin, you wouldn't have a hair follicle, you wouldn't have a hair shaft, you wouldn't have a sebaceous gland, you wouldn't have an erector pili muscle, you wouldn't have any of those things. What you would have eccrine sweat glands, and you would also have Meister's corpuscles. So palms, soles, lips would have the Meister's corpuscles. They would have the eccrine sweat glands, but not the apocrine sweat glands. And no sebaceous glands either. So the palms and soles can sweat, but they don't get oily. No sebaceous glands there. Now, eccrine sweat gland has a sweat duct that goes all the way to the surface, forming a sweat pore at the surface. So all these little white circles that you see are the sweat pores of eccrine sweat glands. That's an apocrine sweat gland, larger body, very short sweat duct, and the pore opens below the surface. The pore actually opens along a hair shaft, as you see here. So it does not make it to the surface. And so we find eccrine sweat glands or American sweat glands in all skin everywhere. You cannot get away from them. They are everywhere. But the eccrine sweat glands are only found in certain regions of hairy skin. You see that? So the eccrine sweat glands are not, there isn't any hair for it to be associated with. There is hair over here, and yet this eccrine sweat gland goes straight to the surface avoiding the hair. It's independent of hair.
So what's the difference between the apocrine and the subscaceous?
And the
subscaceous?
sebaceous?
Sebaceous.
Okay. Well, sweat glands produce perspiration. Sebaceous glands produce an oily secretion called sebum. So I'm talking about if you have oily skin or dry skin, people with oily skin have more active sebaceous glands. People with dry skin have less active sebaceous glands, essentially. But the sweat glands, the sudoriferous glands, the eccrine type, they produce sweat, they produce perspiration, which is essentially salt water. Especially here, the eccrines produce a saltwater sweat.
Mm-hmm.
Apocrine sweat glands produce a saltwater sweat with sloughed-off cells added to it. So the gland actually sloughs off cells. So it's a thicker, more viscous kind of sweat. The interesting thing about that is, as that sweat gets up here, bacteria love those dead cells. They are like favored food to them. So bacteria colonize the regions where we have apocrine sweat glands. Where are they located? Axilla, meaning armpit. So there are 3 hairy regions of the skin where these sweat glands are concentrated. The underarms and the groin, the left and right axilla and the groin. But you also have these guys there too, because they're literally everywhere. So the thicker sweat, the cell-laden sweat put out by this type of sweat gland, bacteria colonize that, feed on the cells, reproduce, more bacteria feed on the cells, they produce bacterial waste products, and the longer those bacterial waste products accumulate, the funkier their odor. So BO is actually a consequence of the building up of bacterial waste in the armpits and groin. Okay?
Thank you.
Was that something you'd love to share with your friends?